Welcome you all. Myself Nagarajan, Assistant Professor in AC Department, Rohini College of Engineering and Technology. In this course, let me share about the biomedical engineering subject, embedded system and IOMT. So in this topic, challenges in embedded system design. When we designing a embedded system, what are the challenges we faced for a embedded engineer? First one is a resource constraints. The limited processing power. Embedded systems often use microcontrollers with lower clock speed and fewer cores compared to general purpose processor. Designer must optimize software algorithm to ensure efficient use of the processor capability, balancing performance with the energy consumption. Next one is a memory constraints. Embedded systems typically have limited RAM and storage, necessitating efficient use of memory resources. Techniques like memory comparison, efficient data structure, and careful management of stack and heap usage are critical. The next one is energy efficiency. Many embedded systems operate on battery power, making energy efficiency a primary concern. Power saving techniques include dynamic voltage and frequency scaling, sleep mode, and optimizing mode to minimize power hungry operations. Next challenges of when we designing a embedded system designer, it is a real-time constraint. In the real-time constraint, first one is a hard real-time system. These systems have strict deadlines that must be met to avoid catastrophic consequences. Examples including automatic airbag system and medical devices. Designer must ensure that tasks are scheduled and executed within their deadlines, often using real-time operating system with deterministic scheduling. The next one is a soft real-time system. These systems have more flexible deadlines, while occasional delays are acceptable but can degrade performance. Examples including multimedia playback and network routers. Designers may be techniques like task prioritization and adaptive scheduling to balance responsiveness and performance. Next challenges is a reliability and safety. Fault tolerance. Embedded system in critical application must continue to operate correctly even in the presence of a fault. This requires designing for redundancy, error detections, and recovery mechanisms. Examples include using watchdog timer to reset the system if it becomes unresponsive and implementing checksum verification for data integrity. And next is a compliance with safety standard. Many embedded systems are subject to industry specific safety standards such as ISO 26262 for automotive safety or IEC 60601 for medical devices. Compliance involves rigorous testing, validation, and documentation to ensure that the system meets safety requirements and can be certified for use. Next challenges is here integration of hardware and software. In hardware and software integration, let us see the hardware software co-design. Embedded system require close integration between hardware and software components with the design decision in one domain after impacting the other. Co-design techniques involve parallel development of hardware and software with iterative testing and refinement to ensure seamless operation. And next one is a firmware development. Firmware is the software that directly interact with the hardware. So managing low level functions like device initialization, input output operation and power management. Firmware development requires deep knowledge of the hardware as well as efficient coding practice to minimize resource usages. These are the integration of hardware and software. And next one is a security concerns. Under the security concern, first one is a cyber security. Embedded systems are increasingly connected to network, exposing them to cyber threats such as a malware, unauthorized access, and data breaches. Security measures include encryption, secure boot processor, and regular firmware update to address vulnerabilities. Physical security. So these are the security concern. Embedded system deployed in the field such as in IoT devices or industrial controllers may be vulnerable to physical tampering. Designers may incorporate tamper-evident seals, secure enclosures, and hardware-based security modules to protect the system from physical attacks. So in challenges when we designing a embedded system design, the designer will face these resource constraints, real-time constraints, and reliability and safety, then integration of hardware and software, security concerns. These are the when we embedded system designer facing the challenges in the embedded system design. Thank you.